So in the previous video, we wrote a solution for Howler, and I hope that you understand that well. But I want to point out that there's a real dangerous bit of code lurking here that could really bite us if we try to use this on a very, very large file. So in my work daily, I work with genomics data, so where we are sequencing organisms or all the DNA in a given environment. And the result of that can be sequence files that are gigabytes and gigabytes in size, sometimes hundreds of gigabytes in size. And so if I were to try to call open on that file and then call read and put that into a variable, that would mean that I would need to have as much memory, more memory available in my computer than how big the file is. So if it's 200 gigabytes, I'm going to need more than 200 gigabytes of free memory. And on some of the machines that I get to use, I have a lot of memory, and I may have that much memory and may be able to use that. But it's a very, very bad idea to read an entire file into memory unless you're absolutely positive that you can handle it. So I'd like to show you how to write a low memory version of this, one that would only handle the text one line at a time. And to show you this, first I want to talk just a little bit about how we can represent text inside Python. So I'm going to go into the REPL here, and I'm going to import the IO module so that we can use this string IO, import IO, and I'm going to represent some text here as a string IO object. And here, for instance, I'm saying foobar baz. Great. So that's this bit of text. It looks like this. And when I try to print it, it shows me it's this object. So it's basically this wrapper. It's kind of like a file handle now. And you see here it's foo, new line, bar, new line, baz, new line. So it's kind of like a file that has foo, bar, and baz on 3 separate lines, separated each by new lines. I can treat this like a file handle, and I can iterate over each one of those lines of text. So in Python, if I use a for loop on an open file handle, it will basically break up the file on those new lines and give me each line of text from a file. And I can show you that. For line in text, print the line. And it prints foo, bar, and baz. Now, why does it put 2 new lines in between? Well, it's because there's already a new line on the line. So it doesn't remove the new line. It gives it back as foo and then new line. And then when I print it, it also automatically puts another new line on there. So that has been exhausted now. So if I were to try to run that again, I should see nothing because it's just like a file handle. I've exhausted the stream. So let's go back, and I just want to talk, let's reestablish that again. And then I want to show you, if I don't want that extra new line to print at the end, I can say print line end is equal to the empty string. And now it will print foo, bar, baz. Okay, that's important because I'm going to show you how to incorporate that idea so that it will, so we can treat the text like it's an open file handle, whether it's coming from an actual file or just a line of text from the command line. And so what we're going to do here is, if this file, if the text argument is a file, we're going to open that file, and we're going to open it as a file handle. And we're not going to read it into a bit of text. It's going to be a file handle. But if it's some bit of text exactly from the command line, then what we want to do is make it pretend, we're going to wrap that and make it pretend like it's an open file handle. So let me show you how that's going to work in our code. If it's true that this is a file, we're not going to do any of this read strip. We want to overwrite args.txt to be a file handle, which means that the else condition will mean that args.txt text, is going to need to be something that behaves like a file handle, even though it's actually literally a string. And we can do that with the IO string IO of args.text. So either way, this should pretend like it's a bit of text. Now, we need to add a new line on the end because text that's coming from a file is going to have this terminating new line. So we basically want this to pretend like it's coming, no matter where it's coming from, that it looks exactly the same, which is what we did in the previous version when we did open read rstrip, where we were getting rid of that new line. Now we're kind of taking the opposite approach. Well, if this is a file, we're going to read that file line by line. But if it's a bit of text, we're going to make a mock file handle so that we can pretend it's a file. This is going to change the way that this works. The output file handle is still the same. I'm not really a big fan of that. But now what we're going to do is we're going to iterate over the lines in the file handle. So for line in args.text, now what we're going to do is we're going to write that the line upper. And then when we're done with this loop, then we'll close the file handle. So to review, what I've done here is args.text is going to be changed from some string, and if that string names a file, an actual existing file on disk, we're going to open that file, and args.text is going to be a file handle. Else, if it's just some text from the command line, we're going to wrap it in a string IO so we can pretend it's a file handle. And then here, we're going to iterate over the lines in that file. So if this were a 10,000 line file or a 1,000,000 line file, we'd only be reading in one line of text at a time. And so we'd only have to allocate memory for that one line at a time. We'd handle each line, and then when we're done with that line, we move on to the next line. So we're not allocating memory to read the entire file, only enough memory to read each line at a time. This should work exactly the same functionally. It's not, let's see what we're getting here. It's always a good teaching moment, standard out. All right, what have I done wrong here? Let's look at our problem, see if there's anything. Undefined variable IO. Great, I forgot to import IO. Let's try that again. Let's go back to our terminal. Let's run make test. And then almost, oh, I think I know what I did here. Because I'm writing with this. I'm adding an extra new line. Let me just verify this and then I'll explain that to you. Yes. So what's happening here, the reason why before I was adding a new line was because I was assuming that I was getting all of this text and it had been, the new line needed to be added to the end. Here I'm iterating over the lines of text, so this could be an input file, a very long input file. So for instance, let's in the inputs directory is, for instance, the preamble to the Constitution. And this is what it looks like. So several lines of text. So it's going to read the first line, and when it does forward line in args.text, it's going to read this line, and there's still going to be that new line attached here because I didn't specifically remove it. So when I write it, all I want to do is uppercase the text. Nothing's going to happen to the new line. It's still going to be there. It's going to be left alone. So when I write it, if I write it and then also add a new line, it's going to add an additional new line so that's what the output. So if I go back and write this and show you this, that if I run Howler with inputs preamble, you see that it writes it with extra new lines in between. What I need to do is get rid of that. It's tricky, and if it bothers you, sorry, but that's the way it works. So this works, and if I run make test, I can verify that this works just fine. So that is the low memory version of Howler. I hope that makes sense. I hope you understand why understanding a little more complexity actually makes for a far more flexible and memory efficient program.